Alright, this is Edgenuity, Algebra 2B, the fundamental theorem of algebra quiz. So let's get started. I just found out that my questions are going to be different than yours, but you can use my as a reference. Alright, so the first one, it's asking you that if f of x is a third degree polynomial function, how many distinct complex roots are possible? So let me explain to you what's going on over here. So if I say that f of x has a third degree polynomial function, means that the highest degree, it's going to be x to the third power. I'm just going to randomly write the rest. But the most important thing is that you're going to focus on the highest degree, which is 3. The degree equals to 3, which means that you can make analysis on this. So, which means that you could have 3 real numbers and real number solutions, or the theorem tells you that you could have 1 real number, I call it Rn, solution. Okay, so which tells you, or which brings you, if I have 3 real number solutions, and because the degree is 3, so the total number of solution, so the total can only be 3. Okay, so if all my solutions are real numbers, which means that complex, so complex means imaginary. Okay, so that left me with just 0 imaginary solution, because 3 real number solution and the total has to be 3, which means that the imaginary has to be 0. For the real number one, if the second case scenario is that 1 real number solution, that brings you to 2 imaginary solution. Okay, so your answer is going to be 0 or 2. All right, so these type of problems are pretty easy. So how many roots existed for the polynomial function? So all you need to do is look at the highest degree. It's what, 7, right? So it's going to be 7 roots. All right, so how many x-intercepts appear on the graph of this polynomial function? So you cannot just go like, oh, okay, look at the highest degree, that's 4, and so there's going to be 4 intercepts. Okay, this is wrong, okay? All right, so this is what you're going to do. So you have to set this whole entire expression equal to 0. So x to the 4th power minus 5x to the 2nd power equals to 0. Then you're going to solve for x. So factor out the x squared. Okay, so I'll just put parentheses over here. Okay, so by the fundamental theorem property of zeros, when you see this, you can set each expression inside of parentheses equal to 0. Okay, so you're going to get x equals to 0. This is your first x-intercept. X squared minus 5 equals to 0. So let's solve for x over here. X squared equals to positive 5. And then you square root both sides. X equals to positive negative square root of 5. Okay, so that means that you got your second and your third. Okay, so second will be the positive square root of 5, and the third one will be a negative square root of 5. Okay, so you got a total of 3 roots, 3 x-intercepts. All right, so according to the fundamental theorem of algebra, how many roots existed in here? So, like what we did earlier, just look at the highest degree, 5 roots. Those are like the gimmies. All right, so how many x-intercepts appear on the graph of this polynomial function? So this is another similar questions. You have to set it equal to 0. And for this one, I'm going to rewrite it out. Okay, so you have to use the method called grouping. So you're going to have to factor out the x cubed. Okay, for the second, okay, so I skipped something. So when we're doing the grouping, how do I know we have to use the method of grouping? Let me go back. Okay, so when you see four different variables, or I should say four different terms, and they ask you guys to factor it, they usually require you to, it requires you to group the first two and the last two. Okay, so I'm going to factor out x cubed from the first two, plus I'm going to factor out x from the second two. Okay. All right, so if you factor out the x cubed, that left you with x minus 1 over here. And if you factor out the x from the second pair, it's going to be x minus 1 as well. Okay, that allows you to okay, so you can rearrange this. So that will be x cubed plus x multiplied by x minus 1 equals to 0. Okay, so by the zero property theorem, you have to set both expression inside the parentheses equals to 0. So in this case, x minus 1 equals to 0, x equals to 1. That's going to be your first x-intercept. Okay, x cubed plus x equals to 0. The only way that this could happen is when x equals to 0. So your second x-intercept is going to be 0. So you got two different x-intercepts. Your answer is going to be 2. All right, so another one. Which one has exactly 11 roots? So this is the one you just kind of pick and choose. So you got to understand one thing. The power is going to distribute to the highest one. So, and you just need to look at the highest degree. In this case, this is going to be x to the 5th power times 6 power, which is going to be x to the 30 power. So this one cannot be correct. Okay, so you just kind of pick and choose. I'm gonna just do all the ones that's not correct first. So this one is power of 5, right? So which means that the degree is 5. So it only has 5 roots. So that one's wrong. And then the first one, because the 11 distributes to the x to the 1st power, so that gives you x to the 11th power multiplied by, here's another x, multiplied by x. So this is going to be x to the 12th power. We need to look for the 11th power. So this is wrong. So I'm going to show you guys the correct one, because the 3 distribute to the first x to the 1st power. So that gives you x cubed right here. The highest degree is x cubed. For this one, it's going to give you x squared, and then 4 is going to distribute to 2. So 2 times 4. So that gives you x cubed times x to the 8th power. And when you're multiplying the various variables with exponents, you're going to add them up. So x to the 11th power. So your answer is going to be this second one. All right, so which following statement is true about the polynomial functions f of x? So if I say f of x has one root, that is 1 plus 13i in this case. So this is called a complex number. Okay, so I'm going to give you guys the explanation of what complex number means. So a complex number have a first component, real number part, and then the second part is imaginary. Okay, so basically, if I say that this is my first root, okay, your second root is gonna have a real number, and then sign is gonna be the opposite, so it'll be subtracting 13i. Okay, so in this case, that would be your answer. All right, so according to the fundamental theorem, all right, so which one has 8 roots? So you can just kind of look. If you, I'm gonna give you guys all the wrong ones first. So 4 distribute to 4, so 3x to the 4th power times 4. Actually, we're gonna ignore the coefficient. All we need to worry about is the exponents. So for this one, it's gonna be x to the 16th power. Okay, wrong. So this one distribute to 2, so x squared times 3, so that's going to be x to the 6th power, so that's going to be 6 roots, wrong. For this one, you have x to the 8th power times x squared, which is going to give you x to the 10th power, so that's going to be giving you 10 roots, wrong. Okay, so last one, you have x squared, let me use a different color. So you got x squared times x to the 6th power. So that's x to the 8th power. So 8 roots. That's the one we're choosing. All right, so if 9i is a root of a polynomial function, what's going to be the other one? So think about that. I told you guys about the complex number. Okay, you got the real number, and you got the imaginary. Okay, so in this case, if I said that one of the roots is 9i, okay, think about that in real number. The real number part is 0, so let's just say it's 0 plus 9i. Okay, that's my first. The other one has to be 0 minus 9i. Okay, so that's just negative 9i. That's your answer. All right, so the last one. So which one has exactly 6 roots? So we're just dealing with roots. So basically, you can look at it right here. Got 4 roots, 5 roots, 5 roots, 6 roots. Okay, so your answer is going to be the last one. You don't even need to do calculation. As simple as that. Okay, so I hope that helps. And then make sure you guys do the assignments on your own, and then use my video as a reference to finish your quizzes. Peace.